When the news first broke, the internet reacted instantly. People laughed, commentators mocked, memes exploded. Only in Florida. The claim sounded ridiculous. Florida had released thousands of snake-killing creatures into the wild. To many, it felt like desperation. To others, stupidity. To some, a bad science experiment waiting to go wrong. But here's the uncomfortable truth. Florida was not acting randomly. Florida was acting out of necessity. And the decision was not as reckless as it looked. To understand why, you have to understand the crisis Florida was facing. A crisis that most people outside the state never fully grasped. For years, Florida has been fighting an enemy that doesn't belong there. An invasive predator that spreads silently, reproduces aggressively, and reshapes entire ecosystems. Invasive snakes. Not one species, not a small population, but tens of thousands, possibly more. These snakes didn't just survive, they thrived. They ate native birds, they wiped out small mammals. They competed with alligators. They broke food chains that took thousands of years to form. And worst of all, they had no natural enemies. Traditional methods failed. Hunting didn't scale. Trapping barely made a dent. Bounties helped headlines, not ecosystems. Florida wasn't losing a battle. It was losing time. Scientists warned that if nothing changed, entire sections of the Everglades would become biologically unrecognizable. Species would vanish, not dramatically, but quietly. That's when an idea resurfaced. An idea so controversial that most officials didn't want their names attached to it. Biological control. Using living organisms to suppress invasive populations. It's a strategy as old as agriculture, but also one of the most misunderstood. When done poorly, it creates disasters. When done carefully, it can save ecosystems. Florida knew the risks. They also knew doing nothing was worse. So when scientists proposed releasing thousands of carefully selected, tightly studied organisms, creatures that could target invasive snakes directly or indirectly, the reaction was predictable. People laughed. Fight snakes with more animals? Have they learned nothing? This will just create a new problem. The ridicule drowned out the science, but behind closed doors, something else was happening. Years of modeling, decades of ecological data, strict containment studies, worst-case scenario planning. This wasn't a viral experiment. It was a last resort strategy. And here's the part most people missed. Florida didn't release these creatures blindly. They released them precisely where the data said it mattered. And the results? Early, quiet, and deliberately underpublicized, began to challenge the jokes. Snake movement patterns changed. Nesting success dropped. Juvenile survival declined. Not overnight, not dramatically, but measurably. The laughter didn't stop because the truth wasn't loud. It was technical. And technical truths don't go viral. But in the years that followed, biologists started to notice something unsettling and fascinating. The ecosystem was responding. Not collapsing, not spiraling. Responding. Which forced an uncomfortable question. What if Florida wasn't reckless? What if Florida was right? And what if the joke was on everyone else? When headlines said Florida released snake-killing creatures, they left out the most important detail. Florida did not release monsters. Florida did not release predators at random. Florida did not gamble blindly with the ecosystem. What they released was something far more specific and far more controlled. The creatures were not large animals meant to hunt snakes directly in dramatic fashion. There were no super predators roaming the Everglades, no invasive mammals, no cinematic battles. Instead, scientists targeted the weakest link in the invasive snake's life cycle: reproduction. egg survival, juvenile growth, early-stage vulnerability. Because you don't defeat an invasive species by killing adults alone. You defeat it by preventing the next generation. The organisms Florida released were biological control agents, species that naturally limit snake populations in their native environments. After years of study, researchers identified creatures that met 3 strict criteria. They could survive Florida's climate. They specifically disrupted invasive snake reproduction. They posed minimal risk to native species. This was non-negotiable. Every candidate that failed even one criterion was rejected. The most effective agents were highly specialized. They targeted snake eggs, juvenile snakes, or the parasites that snakes depend on to survive. Their biology made them ineffective against birds, mammals, and reptiles that Florida needed to protect. This specialization is what separates modern biological control from past disasters. In the past, broad predators were released with little testing. They adapted too well. They ate everything. Ecosystems collapsed. Florida's approach was the opposite. The goal was constraint, not dominance. Before any release happened, the organisms were tested in containment facilities for years. Scientists simulated worst-case scenarios: population explosions, mutation potential, food scarcity, accidental spread. If a species showed signs of adaptability beyond its target, it was eliminated from consideration. If it reproduced too quickly, rejected. If it could switch prey, rejected. If it survived outside controlled zones, rejected. The final selection passed hundreds of stress tests. And then came the most controversial decision. Scale. Florida didn't release dozens. They didn't release hundreds. They released thousands. Because biological control doesn't work at symbolic levels. It works only when introduced at a density that can actually compete with an invasive population already numbering in the tens of thousands. This is where public perception collapsed. People imagined chaos. Scientists saw math. Every release zone was chosen using satellite data, snake tracking, and habitat modeling. The creatures were not dumped randomly. They were placed where invasive snakes bred most heavily and where native species were least exposed. This wasn't spectacle, it was surgical. Even the timing mattered. Releases were synchronized with snake breeding seasons. Not to create shock, but to interrupt momentum. To ensure that the next generation would be smaller than the last. Quietly. And something else rarely mentioned. These organisms were not expected to live forever. Many were self-limiting. Once snake populations declined, their food source declined too, naturally reducing their own numbers. No endless expansion, no permanent takeover. Built-in breaks. This design choice was intentional and critical. By the time the public noticed anything at all, scientists had already been monitoring the results for months. Snake egg viability decreased. Juvenile survival rates dropped. Breeding success declined in targeted zones. No dramatic headlines, no viral videos, just data. And the data told a story that memes never could. Florida hadn't created a new invasion. They had applied pressure, precise, targeted, and reversible. The creatures weren't replacing snakes, they were rebalancing the system. This is why biologists were cautious about celebrating, because biological control does not offer instant victory. It offers time. Time for ecosystems to recover. Time for native species to rebound. Time to slow a disaster before it becomes irreversible. The internet laughed because it expected spectacle. Science delivered restraint, and restraint rarely trends. But as the months passed and the data continued to hold, the laughter began to sound premature. At first, nothing looked different. No dramatic die-offs, no sudden silence in the wetlands. No visible collapse of snake populations. And that was exactly what scientists expected. Biological control does not announce itself. It works quietly, beneath the surface. The first signs appeared not in body counts, but in patterns. Tracking data from radio-tagged invasive snakes began to shift. Females altered nesting behavior. Nest sites moved. Clutches were smaller. Hatchling survival declined. Not everywhere, not instantly, but consistently in the release zones. This was critical. It meant the effect was localized, targeted, and controllable. Researchers compared control areas, where no releases occurred, with treated zones. The difference was subtle, but statistically significant. Egg viability dropped. Juvenile growth rates slowed. Early mortality increased. No single metric proved success. Together, they told a story. The snakes were still there, but they were no longer winning. One of the most unexpected findings involved behavioral stress. As egg and juvenile survival declined, adult snakes expanded their movement ranges. They traveled farther, took greater risks, and entered less optimal habitats. This mattered. Stress behaviors increase exposure. Exposure increases vulnerability. Vulnerability accelerates decline. Not through force, but through pressure. The system was bending, not breaking. Scientists also monitored native species closely. Birds, small mammals, reptiles, anything that could signal unintended consequences. The results were reassuring. No population spikes of the released organisms outside target zones. No measurable harm to non-target species. No cascading disruptions in food webs. This was the nightmare scenario everyone feared. And it wasn't happening. Instead, something else began to occur. Native prey species, long suppressed by invasive snakes, started to rebound in limited areas. Nesting success improved. Sightings increased. Not enough to declare recovery, enough to declare potential. This is where scientists became cautious. Success in ecology is fragile. Push too hard and balance flips. Move too fast and systems collapse. Florida's team resisted pressure to expand the program immediately. They slowed down. They gathered more data. They ran longer models. Because early success is when mistakes are most tempting. The goal was not eradication. It was stabilization. One detail stood out above all others. The released organisms did not spread uncontrollably, even when conditions were favorable. Their populations rose slightly, then plateaued. When snake reproduction declined, so did the agents. The brakes worked. This validated years of containment testing and selection criteria. The system behaved as designed, rare in ecological interventions. Still, scientists refused to declare victory. Ecosystems respond over years, not months. Invasive species can rebound if pressure eases. Climate shifts could change outcomes. Human interference could undo progress. Caution was not pessimism. It was responsibility. Public reaction, however, lagged behind reality. Most people still believed Florida had done something foolish. The story was too complex to go viral. Success without spectacle rarely spreads. But within scientific circles, tone began to change. From skepticism to curiosity to guarded respect. The question was no longer, will this backfire? It became, how far can this go without crossing the line? Because every tool that works can also be misused. And that brings us to the hardest part of the story. Not whether Florida's plan worked, but whether humans can resist the urge to push it too far. Even as the data improved, the celebration never came. Because every ecologist in that room understood one thing. Nature does not forgive arrogance. Florida's plan showed promise, but promise is not permission. History is full of biological control efforts that started with confidence and ended in catastrophe. Cane toads, mongooses, invasive beetles. Each began with good intentions, each underestimated complexity. The scientists behind Florida's program knew they were walking on a knife's edge. The greatest risk was not what was happening, it was what might happen if conditions changed. Climate shifts could alter breeding cycles. Flooding could move organisms beyond containment zones. Human interference could transport them unintentionally. Even a perfectly designed system can fail when the environment rewrites the rules. This is why Florida built redundancy into every stage of the program. The released organisms were not only biologically limited, they were continuously monitored. Population sensors, field surveys, genetic sampling. If unexpected spread occurred, the response plan was already written. Immediate suspension, targeted removal, chemical or biological countermeasures. No improvisation. Scientists also feared something less obvious: success itself. If the program worked too well, political pressure could demand expansion. Other states might copy the idea without the same rigor. Corners could be cut, oversight weakened. This is how good science becomes bad policy. Florida's team repeatedly warned lawmakers this was not a template, it was a case study. Transfer without caution would be reckless, but restraint is difficult when results look promising. Another fear involved public misunderstanding. Headlines simplify. Social media distorts. The phrase snake-killing creatures attracted attention, but hid nuance. If people began releasing similar organisms on their own, chaos would follow. Biological control only works when centrally coordinated. Unregulated imitation is disaster. To counter this, Florida quietly invested in public education. Workshops, academic papers, controlled disclosures. They avoided spectacle deliberately. No viral announcements, no victory laps, just peer review. The world's ecological community noticed. Researchers from Australia, South America, and Southeast Asia began observing closely. Regions facing invasive species crises saw Florida as a possible last resort model, but only if the safeguards held. This made Florida's responsibility even heavier. If they failed, they wouldn't just damage the Everglades. They would poison the idea of biological control for a generation. This is why expansion was slow. New release zones were approved only after months of additional data. Independent oversight committees reviewed every step. No shortcuts, no political deadlines. The scientists understood something politicians often forget. Ecosystems do not care about urgency. They respond only to pressure applied at the right scale. Too little, and nothing changes. Too much, and everything breaks. Florida was trying to balance on that narrow line, and so far, they hadn't crossed it. But the question remained, was this controlled success sustainable? Or was it merely the calm before an ecological backlash? That question still had no final answer, which is why scientists refused to call this a victory, even as the data improved. Because the true test of this experiment was never the first year. It was what happened after confidence set in. And confidence is when humans make their worst mistakes. In the end, the most shocking outcome was not what Florida released. It was what the release proved. That invasive species are not invincible. That ecosystems are not as fragile as we fear, nor as forgiving as we hope. And that human intervention, when restrained and precise, can correct damage without replacing it. For years, the dominant belief in ecology was simple. Once an invasive species reaches a certain scale, control becomes nearly impossible without catastrophic side effects. Florida challenged that belief. And quietly, methodically, it survived the challenge. The data collected over successive seasons told a consistent story. Invasive snake populations did not crash. They declined gradually. Reproduction slowed. Expansion halted. Pressure shifted. This mattered more than eradication, because eradication destabilizes systems. Balance restores them. Native species began reclaiming space. Not everywhere, not instantly, but measurably. Food chains showed signs of repair. Predatory pressure redistributed. The ecosystem didn't flip. It recovered. This outcome stunned critics for one reason. Florida resisted the human instinct to dominate. They didn't try to eliminate the snakes overnight. They didn't unleash unchecked predators. They didn't chase headlines. They applied constraints. That restraint changed everything. What Florida proved is now being discussed quietly in scientific journals around the world. Biological control does not have to be reckless. Intervention does not have to be destructive. And do nothing is not the only ethical option. The real danger, scientists realized, was not intervention itself. It was impatience. Every ecological disaster linked to biological control shared the same flaw: speed without humility. Florida moved slowly, measured constantly, stopped when uncertainty increased. That discipline is why the experiment held. The laughter stopped, not because Florida defended itself, but because the numbers did. And numbers are difficult to argue with. This does not mean the story is over. Ecosystems evolve, climate changes, new pressures emerge. Scientists remain cautious, and they should. But one thing is now clear. Florida didn't release chaos. They released pressure. Pressure that nature knew how to respond to. This reframes how the world may approach invasive species crises in the future. Not with panic, not with brute force, but with precision. It also reveals something uncomfortable about us. We laugh at complexity because it feels dangerous. We mock restraint because it feels weak. We prefer spectacle to patience. Florida chose patience, and patience worked. The truth that stunned everyone was not that the plan succeeded. It was that success came from doing less, not more, from understanding systems instead of overpowering them, from respecting nature's limits, including our own. This experiment may not become the model for every ecosystem, but it changed the conversation forever. It proved that humans are not only capable of breaking nature, they are also capable of repairing it when they stop trying to be heroes and start acting like stewards.